Right? See the problem. Given an array of n elements, majority element is an majority element in an array A of size n is an element that appears more than n by 2 times in the array. Return if majority element exists, otherwise return minus 1. If anyone is not clear, let me check once. In this array, first element, second element, third element, fourth element, fifth element, sixth element, 7 elements. 7 elements are there. What is 7 by 2? 3.5. More than 3.5. More than 3.5. It may be 3.6, 3.7, whatever it is. More than 3.5. It may be 3.5. Because of elements here, more than 3.5. Maybe you can take 4 also. Is there any element which is repeating in the given array 4 times or more than 4 times? Let's check. 1, 2, 3, 4. 4 times one person repeating. So this person is called majority element. So majority element exists. So you have to return him. In the given array, if majority element exists, return that person. What is a majority element definition? In the given array, an element is said to be a majority element if that element is appear more than half. Half is 3.5, half is 3.5, more than half, more than 3.5. Because of number of elements, more than 3.5 is, I think, 4. 4 or 5 and so on. I taken 4. So one person repeating 4 or more than 4. I think majority element exists, that is 13. Can you see one more example? First element, second element, third element, fourth element, fifth element, sixth element, seventh element, eighth element. 8 by 2, 4. More than 4, more than 4. That is going to be 5, 6, 7 and so on. Any person in the given array who is appearing 5 or more than 5 times. I think 1, 2, 3, only 3 times. Majority element not exist, return minus 1. In the similar way, can you see 1, 2, 3, 4, 5. In the given array, 5 people are there. 5 by 2, 2.5. More than 2.5. That may be 3. Any person is there in the given array 3 or more than 3 times. Yes, there. So majority element is 81. So you have to write algorithm. If majority element exists, you have to return him. Otherwise, return minus 1. You have to plan one algorithm for this. Let's see how you are going to do. It's one of the famous problem of computer science. So what you want to say is you have to find out majority element in the given array. In the given array, if any element is repeating more than half time, if any element repeating more than half time, that person is majority element. I think in this array, if you observe, right, one person repeating more than half. So 13 is the answer. In this array, if you observe, I think elements are 1, 2, 3, 4, 5, 6, 7, 8. 8 people are there. 8 by 2 is 4. So I think someone should repeat 5 or more than 5. Then only is a majority element. Is there anyone repeating more than 5 or more than 5? Anyone? I think it is repeating only 3 times. Right? So majority element not exist, then you have to return minus 1. Right? Next one. Similarly, like this. I think here 5 people. 5 by 2, 3 point, right? So 2.5. More than 2.5, maybe 3. Right? Anyone repeating 3 times. Yes. So majority element exists. So we have to find out. This is the challenge what we given yesterday. Right? Let's see the answer for this. I hope you tried it. Let's see the answer. Yeah, I written the code also. It is a very simple algorithm. It's a Python program. So please write properly. I written the rough code. So what exactly this program is? So you have to find out the right majority element. So these are the elements. Let's write the elements one time. 55, 65, 30. Next one is 80, 30, 30. So total I think 6 people. 6 by 2 is I think 3. Let me write one more time. 30. So I think totally 7 people. Majority element exists. That is 30 everyone. 1, 2, 3, 4, 5, 6, 7. So what is the one simple idea? What is the one simple idea is take the element 55. Count how many times 55 will come. Take the first element. See. For I in range n. So take the first person. Right? First person you take. Make the count as 1. Index is I. Index is 1. right? Take the first person. Now that will be compared with all other people. So like this, right? This will be compared with all other people. Is there anyone exactly like me? So I think I done the counting. 55 counting done. Lastly check, right? Count is greater than n by 2. No. No, if it is not, here if it is true, return. If not, execute the code. This loop is going on. This loop is going on. Right? Remember, this code is belongs to this. This code is belongs to this. Right? So this code is belongs to this. Please careful. Be careful with the spaces. Python programming, space important. You have to give spacing properly. In C language, it may not be big problem because the brackets are there. But in the Python language, no brackets and all. You have to keep space properly. See, this for loop story, let these people inside. This for loop story inside. This definition story inside, like that. So for each person, do the counting. I done the counting of 55. Only one time happened. As soon as you select this person, count is 1. Is index also I1. So you keep on count. If you after counting, count is greater than n by 2, then is the mid element. He is the actual majority element. If not, right? I value 2. So count becomes 1, index becomes 2. Now that will be compared with all other people. So I plus 1 onwards it will. So I think if you take this one, it will be compared with all other people. So like that it will be keep on going on. So every person you have to compare with all other people, n. Every person approximately n. Every person approximately n. Like that it is going on. Worst case, this algorithm will take order of n square time. Order of n square time complexity. So if I want to say to be frank, first person, right? First person, n minus 1 comparison. Second one, n minus 2 comparison. Third one, n minus 3 comparison. And so on. Lastly, 2 and 1. It is the sum of n minus 1 natural number. To be frank. Sum of n minus 1 natural number, n minus 1 into n by 2. Which is going to be order of n square. This is the time complexity for this. What is the space? I am not taking anything extra. Constant space. Space complexity, constant. Right? Everyone know this. Everyone. So this is the almost like main program. From main program, I took one array. In Python programming language, there is no main like that. So this is, I think, outside code, which means main program. So one array I took, which is also called in Python programming language, this is called list. Right? One list I took, length of the list I calculated, which is n. Right? Which is n. Now find majority, array I passed, list I passed, and n also I passed. At the end of the story, you will return whichever is the majority element. So you will return, that will be stored here. You will print that person. Suppose majority element not exist. Right? If majority element exists, you will return here. If majority element not exist, at the end of the for loop, there is a return -1. So you will print -1, something like that. It's very simple. If anyone is not getting, 2 inner loops. Whether you write Python, whether you write C language, it is up to you. C language, Python language, both are same. In C language, brackets are there, or C++ language also brackets are there. Here brackets not there. Space you have to adjust. I hope everyone fine. So the answer for this problem is order of n square, one of the algorithm. But one more famous algorithm there, I written that also. Right? This is the famous algorithm. One more famous algorithm there, I am going to explain that. Please listen roughly. Right? So majority element, I will first explain. Let me explain the majority element, how to find out. So one, yeah, if you want, you can start from 0. Indexes I'm writing. So I think approximately 11 people, 11 by 2, 5 point something. So 6 people. Majority element means 6 people required. So let me try this. So some elements. So 10, 20, 30, 30, 30, 40, 50, 30, 30, 60, 30. I think 30 is repeated more than half. 11 people, 11 by 2, 5.5, more than 5 is 6. So 6 times 30 is there. I hope so. So majority element exists. We want to see answer as 30. How we are going to proceed this? There is one algorithm that is, I think, Morse voting algorithm. Morse voting algorithm. So why it is called voting algorithm is, whenever elections are going on, if anyone got more than 50%, he will be the winner. Right? Comparing all the people, whoever got more votes, whoever got more votes, he will be the winner. Something like voting algorithm going on. Comparing other people, you should get more votes. Right? That's called Morse voting algorithm. Anyhow, right? Something related to voting kind of thing. But don't bring voting, which is a complex area, right? Elections, politics is a dangerous area. Don't bring that story here. This is also called Morse voting algorithm. I am going to explain how it is. Very simple story. Very simple. So let me change the color. Very simple. So let us assume, I started this process. Let us assume that first person. Let us assume that first person. First person is the right majority element. Let us assume. Careful everyone. Let us assume that first person is the majority elements. Majority element index. Majority element index is equal to 0. Assume that first person itself is majority element. So is index I written. And one more, because of already one time first person 10 came, his count is 1. His count is 1. Assume that first person is majority element. So majority element index is 0. Right? So, and one more, one time already 10 came, count is 1. Now what you do is, this person, right? This person, this element 10, compare with the next person. If it is right, if it is equal to the next person, then count will increase. If it is equal to the next person, count will increase. So ask the next person. Next person and the majority element, right? Majority element index is 0, right? A of 0 means this person compare. If both are equal, count could have been incremented. Because of both are not equal, right? I think some other element came. So both will be cancelled. Different element cancelled. So count became 0. And one more thing is, majority element is there at the 0th index, we said. Now no more is not majority element. Now no more is not majority element. Then whenever count became 0, again, right, again I think cancellation is done. No one is good, no one is the majority element as of now. Now again start from second element. What is the meaning? Let us assume that majority element index is 1, count is 1. Start it. Right? So those people who are not getting, very simple. Whenever count became 0, again start from starting process. What is the meaning? Let us assume that 20 is the majority element. So his index is 1, count also 1. Start again. This will be compared with the next element. Are they same? No. If not same means they both will be cancelled each other. So count became 0. Whenever count became 0, then again, right, this process is cancelled. Again majority element index is next element. What is the meaning? 30 is the majority element index. Assume. So index is 2, count is 1 as usual, because one time 30 came. Right? Do the story now. See this one. Do the story. Very interesting. Are they same? Yes. Count will increment by 1. Same means count increment. Not same means count decrement. Again same, count increment. Be careful. Same means very simple algorithm. Yeah. Same person getting more votes, increase. Already one vote came. One more vote, increase. Already one more vote. One more vote, increase. But opposite vote came, cancel it. Because you have to get a finally majority. So to me, opposite person got, cancel it. That is the reason it's called Morse voting algorithm. Until now 30 came 3 times. Now see 40 came. Is 30, 40 same? No. Then decrement. But after decrementing, count is 0. No. If it is 0, you have to start from again. It is not 0, continue, no problem. Next one. This 30 majority element index is 2. With the two person compare. Every time you are comparing majority element index 2 with that person compare. So I think 30 and 40 I compared. There is no equality. I removed. 30 and 50 also compared. Both are not equal. Again decrement. It is not 0. If count 0, then I will start again from starting. Next one. This 30 and 30 both are equal. Yes, 2. This 30 and 30 both are equal. Yes, 3. This 30 and 60 both are equal. No. Cancel. Cancel. Right? I hope everything is fine. Cancel. That is also fine. Next one. So I think cancellation. Next one. This 30 and 30. Yes, increase. Right. So one time scanning is done. I hope everyone is fine. So lastly, after completion of this process, you don't get a majority element. You will get the most probable majority element. So, right, I think most probably majority element exists in the second index. At the end of the story, whoever there in this area, this person is most probable person. Most probably majority element exists. At second index. It will give most probable. Most probably majority element exists at second index. Now some people are asking, sir, what should I do now? Very simple, right? That person only compare. Now this person, second index 30 there, that person, right? Take one for loop or while loop, whatever it is. Count how many times 30 came. Let's check. I will take one scanning. I will count how many times 30 came. 30 came how many times? Let's count. Right? Till now 0. 30 came one time. 30 came two times. 30 came three times. 30 came four times. 30 came five times. 30 came six times. 6, which is greater than 11 by 2. So it's a majority element. So to find out most probable person, one scan required. To find out most probable person, to confirm, one more scan. So n time here, overall 2n, which is nothing but order of n time. And I am not taking any extra space, same array I used. Order of one space. I hope everyone got it. So algorithm also available. Let's come here. Right? I think there are two steps here. Most probable person finding and confirming. Right? Most probable person finding and confirming. See, find candidate. One story. Is majority. One more story. One is for most probable person. One more thing is for confirming purpose. See, this is for confirming. This is for most, right? Most probable person finding. It is the confirmation purpose this. Okay, I think everything is fine. So you can see the story. Whatever I discussed with the help of example, same thing here. See this one. Start here. Majority element exists at index 0. Count is initially 1. Right? 1. Right? Take the 0th person is the most probable. Right? Majority element. So count is because of one time you are taken. Then start the for loop. What is the for loop, right? You have to check this person you have to check with the next one. Who is the next one? 6 1. Majority element, right? A of majority element index is equal to A of I. You are taking one for loop. With the I you are running. So it is keep on going. So whenever it is coming, increment by 1. Suppose opposite is coming, decrement by 1. Right? Next one, if count is 0, oh, so all cancellations done. So again, majority element index will start from I, count is 1, continue this loop again. Same story happening. Right? This is, I think, one for loop is there, one for loop end time. Now next one, after finding, so you will return the majority element. You will return majority elements. Can you see this one? Majority element. So let me go here. Yeah, see. Find the candidate. So let us assume that candidate is 30. So 30K. Now, so is majority. Confirmation purpose go. So I went. So suppose that after completion of take, it's very simple. Take one for loop count. If count is greater than, right, length of A by 2, then return true. Right? Assume that true came. It is true. True is equal to true. Print candidate. So printed over. So first he will call. Then he will call. Right? Afterwards, then he will call. So like this. So if you want, I will give the numbers also. So first it will start from here, 1. It will go here, it is 2. It is 3. It is a 4. That's it. Because of space not available, I written random places. So this is the story. Print majority person. I will go here. Find candidate. So he will give. He given 30. 30. Next one. Is 30 is a majority element. He will go here. Yes, he return true. He return true. So print true. Suppose he return false. Print false. That's it. This is one of the nice algorithm. Time complexity is only order of n. Right? Time complexity is only order of n. So I already explained. So this one will take n time. This also will take one more n time. So total 2n, which is order of n. This is for time complexity. Space complexity, I am not taking anything extra. Space. That's it. I hope you are enjoying the EPP 30 days challenge. I hope you are enjoying. You are really enjoying this. I hope you are really enjoying. Right? Any doubt is there? Right? If you have any better answer, you can type in the comment section. Right? So that we will also improve. Right? If at all any new suggestion there, we will also improve. If you have any doubt, you can ask. We are going to reply. Thank you so much. Thanks everyone.